Welcome to this tutorial. I'm standing in front of the Jülich Supercomputing Center, which hosts, besides a couple of the most powerful supercomputers in the world, the TOAR database. Let us begin. Welcome back. In order to use the TOAR database, we need to type in the URL https join.fzjülich.de. What you'll see is a login window here, and you can also create your own account. If you click on this link, it'll ask you to fill in some personal information, provide your own password, and then if you click on the sign up button, you will be sent an email which we ask you to confirm, and then you can log in. Should you ever forget your password, there's a link here to renew your password. So I will log in with my account now. Log in. And we'll be taken to the starting page, which contains again some information about the Tropospheric Ozone Assessment Report. So here's a link to the project homepage. Here's a link to the article collection in the journal Elementa. Here's a special link to the database article, which contains a more detailed description of it. And we also provide a link here to a collection of dataset with pre-compiled ozone metrics. And those are the data sets that have been used in the articles that you find in the Elementa journal. Please be sure to adhere to our data use policy because indeed TOAR has been compiled and has been made possible only with the help of many individuals and agencies who provided their data, and it would be great if you can acknowledge their efforts. In order to use the web interface for accessing the TOAR database, which I'm going to demonstrate in this video, we click on this left button here. There's also a REST interface available. This will be the topic of a separate video. So we click on the map interface. This displays a global map and a number of filters here on top, and I will explain those filters to you later. It does take a few seconds initially to load because indeed there's metadata of several thousand stations that has to be retrieved in order to display them on the map. So now we see all the stations that are in the TOAR database on this map. There are clusters when the density of stations is very dense. And let me demonstrate how to work with this web interface now at one example. And let's just look for a station in London, Westminster. So we can either, of course, try to locate the station on the map. This is a normal Google Map navigation. So we can scroll in, zoom in, and try to locate the station on the map. Or we can also just use this filter and type in London, Westminster, apply filters, and there we are. There's only one marker left on the map. If we click on this marker, we see a couple of links and some information. So we see here that the data that we're going to look at comes from the airbase network. The station identifier is GB0743A. Station name is London Westminster. We see the station coordinates, and then we see a couple of links to individual species that are either measured at the site, or in the case of these meteorological variables, they were actually taken from a meteorological reanalysis. That means these are model results. Let's take a look at the metadata first. So we click on this link here. And again, we see basically a description of the station, including a characterization, so that this is a background station in an urban environment. See the name again, the country. We have coordinates, we see the time zone, and then we get a couple of metadata elements here. which were all retrieved from global, either satellite or other geoscience data sets, and which make it possible to characterize these stations in a globally unique manner. So examples for this are the nighttime light intensity, which gives an indication about the energy use at this location, climatic zone, wheat production, rice production, emissions of NOx, and so on and so on. One of the things to highlight would be the land cover description, which gives you a percent breakdown here of the environment around the station in a radius of 25 kilometers. There's also then these tabs here for individual measurements and other data variables. Let's take a look at the metadata for ozone. And here we see again just a series ID number. Then we see the sampling type, the measurement method, the original units in which the data were provided in. Please note that all the data that are hosted in the database come in ppb. Then if available, we also store information on the contributor of this data set. And then we note when we actually created this data series, when it was last updated, and from when to when we have data. Okay, let's click on the ozone link here to see how you can actually access the data themselves and work with the data. So this brings up this dialog box here. Again, you see the date range where we have data available for the site. You can select whether you want the data in local time or in UTC or in solar time. So UTC is sensible if you want to do model evaluation, for example. You can select which kind of quality control level you want. So normally we all only include good data or data that have not been checked, so real-time data, for example. But in some cases it may be useful to also include doubtful or wrong data, for example. In principle, it's possible to also look at hourly values, only graphically, however, and this is restricted to 1 year maximum. What I'm going to demonstrate you first is the data summary plot, which generates, on the click of one button, a comprehensive overview of the data at the site. So again, this takes a couple of seconds because it does actually go into the database, retrieves the hourly values, and computes all the various statistics and creates the plots at the time when you click. So there's nothing pre-configured, but it's all done on the fly. So here we have this data summary plot. Again, you see the station location on the upper left with a little bit of metadata information. You see a time series here with the hourly values, and if there are periods of missing data or incomplete data, you either see little triangles if it's a monthly gap, or these bars if, as here, for example, a whole year is missing, or here the entire year has less than 75% data coverage. On the left-hand side, you see seasonal, weekly, and diurnal cycles of the data. The seasonal and the weekly cycles are broken down also by day and night, here and here, whereas the diurnal cycle is broken down by individual seasons. So we have the green line for the annual values, and then we have winter gray, springtime blue, summertime red, and fall is yellow. In the center part of the graph, you see frequency distributions, either split by season again, or here listed for individual years. And we compute a statistics, so-called Earth movers distance, which indicates if a specific year is out of the normal. Then here in the lower part, you actually get to see a preliminary trend analysis. This requires enough data to be available, which is then summarized in these bar plots here, and again with the table values here. So there are two predefined periods, 1990 to 2001 and 2002 to 2013, and then statistics for the entire series. Let me come back to the dialog box from the data selection. So a little further down, you see this table here that contains all kinds of statistics, like the number of values in a given period, the data capture, so the percent fraction of available values, average values, standard deviation, then there are daytime averages, nighttime averages, or daylight averages. So these were computed using the solar zenith angle to indicate daylight. Same for the night time then, dark time. We have median, maximum, minimum values, and there are two groups of percentiles here, so either 25, 50, and 75, or a little larger selection here. Each of these statistics are available either as daily, monthly, seasonal, summer, or annual statistics, and again, they will be computed on the fly as soon as you click the button. As an example, let's look at the monthly daytime averages here. And if you click on this left button here, we'll get to see a plot. Here it is. And in this plot, you can mouse over here and you will see the values of the individual points, data points. You can also zoom in with these little sliders here. You can move the range of the values and so on. Alternatively, we can also download the values. So if you click on the right button here, this little download symbol, another tab will open which displays the data in a simple ASCII format to you. So there's a lot of metadata listed here in the beginning, and then we have the date column and the value column. So it's a very easy format to parse and to work with. Further down, if you look at the ozone data, then we see a second table coming up with specific ozone metrics. So these are special statistics that are in use to evaluate the impacts of ozone on health, vegetation, and climate. Things like the maximum 1 hourly value, the daily maximum 8-hour average value, and this has been computed or can be computed with different definitions of the diurnal time window. There are 3 month running means, some 0.35, some 0.10. These are European metrics for health. W90 is an American metric for health. AUT 40 is a vegetation metric from Europe. W126 again is a vegetation metric from the US. And at the bottom you find exceedance count, so the number of days or whatever that exceed a given threshold value. So to end this demonstration, let me quickly come back to these filters up here. So you can actually configure these filters flexibly. If you go to change filters, there's a number of variables here, a rich selection of metadata attributes. And let me demonstrate this to you with a nighttime light intensity. So you click on this metadata element, and on this triangle here, it will be shifted, moved to the other table. If you click accept, it will appear up here on the filter selection lines. So up to 12 filters are possible. And let's now demonstrate this by selecting all urban sites worldwide. Urban sites are typically well illuminated, so we just restrict this range from 60 to 63. Let's get rid of London Westminster here. Let's also look just at ozone values, so we restrict the search for ozone. And let's apply the filters. This again takes a few seconds now. There we are. This is for Europe. If we want to see the whole world again, we simply go to Reset Map. And there we are. So we see down here that this selection contains now 4,734 data series at almost the same number of stations. And then, of course, you can scroll in again and do the same things that I demonstrated to you before. So now we're scrolling into Japan. And let's just arbitrarily select one site here. And again, we see the station ID, the name, and in this case, we only have one variable, ozone. This ends our demonstration, and by logging out, I quit this movie.